Let's take a look at how we use abstract classes and inheritance to create game levels. Here's the levels demo. The bird needs to collect a number of oranges before being allowed to go on to a second level through a portal. Notice how collecting only a few oranges is not enough to enable the next transition. Once we do collect all oranges, we can go through the door. Our game only has 2 levels, so once we complete level 2 and go through the portal, the game exits. So how is this game implemented? All our game levels inherit from a generic game level class. This class is abstract. It keeps track and initializes some data that is common to all levels. For example, all levels contain a player, the bird, and the door to the next level. There are also a few things that all levels have, but that are particular to each level. For example, all levels have a condition of completion, for example that the player collected a given number of items. But for each level, this condition might be different, for example 3 oranges in the first level, 10 oranges in the second level. There are many other things that could be different. The starting position of the player and the position of the door, for example. We'll handle these in this demo. Other examples, however, include the number of lives that the player is given at the start of the level, or how fast enemies move, the background image shown, or even an audio theme. These things that all levels have but are different for each level, we declare them as abstract methods in our generic game level class. Each actual level that will extend this class will return its own custom value for these methods. For example, level 1 will return one player starting position, level 2 will return another starting position, and so on. Similarly, level 1 could return one background image, level 2 another background image, and so on. But what is a game level after all? Well, notice that game level extends world. So each game level is a different world. So when we start the game, we create one world, game level 1, populate it with platforms, bird, orange, and the door, and allow the player to interact with that world. Transitioning to level 2 involves throwing away the first world, including its bird, door, and everything in it, and creating a second whole new world populated with new bird, new door, new platforms, and so on. We add to game level a method called populate. This is like an initialization method, a method that is responsible for setting up the entire game level. In game level, this method only sets up what is common for all levels. It creates a player, a bird, and a door. The positions at which these two are placed, though, will come from specific level classes. These methods are abstract, they have no concrete implementation here in game level, but they will in concrete level classes. Let's look at the implementation of levels 1 and 2. Both provide concrete starting positions for the player and the door. They also provide implementations for the method that tests whether the level is complete. These are also different. Finally, both override game level's populate method. They still call the generic game level populate method using this super keyword so that the player and the door get created, but then augmented with level-specific platforms, number of oranges, and so on. Okay, enough of the theoretical talk. Let's see how the game runs. We will use the debugger to step right through the game. First, we want to see what happens when the game starts, how the first game level gets initialized. I'll set the first breakpoint here right at the entry in our game. So notice we have a level field to track our current level number, which we initialize to 1. We also create a new level 1 world and link it to this world field. This level 1 world is empty right after we create it, so we call populate to set it up. If we step in, we see that the correct populate method gets called, namely that of level 1. This is what we want, since it's level 1 we are in the process of creating. However, the first thing we do in level 1 populate is to call populate in the base class, in the generic game level. This happens through this super call. If we step into this, we'll indeed see that we are in the game level populate. We now see how this creates a player and a door. But the real interesting bit is that the player gets created and then placed at a position that is given by the start position method in level 1. Indeed, if we step into this start position, we see that this is the start position method in level 1. So yes, we are creating the player in the base game level class, but we are placing it at a position that is determined by level 1. The same is true for the door, but for the door we also attach to it a door collision listener. This will notify us when the player touches the door. Once the player and door have been created and positioned, the populate method in game level is done, and we step out into the more specific populate method of level 1. Here we create a specific ground platform, some walls, and a bunch of oranges. Great, we can step out into our main game. Everything else here is the same as other demos. We attach a view to our world and we start the simulation and so on. The next interesting thing that will happen, and that I'd like to check, is the transition to the next level. When does the transition happen? Well, when the player touches the door, right here. So I will add a breakpoint so that my program will stop and let me step through when the player touches the door. I will press this button here to indicate that I now want to play the game for a bit. So I collect the oranges in level 1 and then go to the door. Sure enough, when I touch the door, my debugging breakpoint gets activated, and I can now step through everything that happens upon level transitioning. The first thing is making sure we are allowed to transition. Is the level's finishing condition true? To check that, I've added this method into the game class called isCurrentLevelCompleted. But if we step into it, we see that this does nothing more than call isCompleted of the current world, and the current world is level 1. Sure enough, if I step into it, I see that I'm in isCompleted of level 1. This condition is true, since I've collected enough oranges, and is returned upwards into isCurrentLevelCompleted, and then further upwards into my door listener where I came from. So this whole thing is true. We can go to the next level. We do this through this goNextLevel method that I've created in the game class. Here's what we see if we step into it. Remember what we plan to do when switching levels. We want to throw away the old world, corresponding to level 1, and we want to create an entirely new world, corresponding to level 2. The level 1, or current level, is given by this world field. Since we don't need it anymore, we stop the physics simulation in it. Since level is currently 1, this doesn't apply, so we go into this branch. Here, we increment level to 2. Then we create a new level 2 world and set our world field to no longer point to the old level, the level 1 world, but to the new level 2 world. Then we populate level 2, and again if we step in, we see that we are in the correct level 2 populate method that we first call the populate method in the base game level class, where we create the player and the door. At this time, the positions are given by level 2. And once we are done there in the base class, we continue with populate code specific to level 2. That is, we add platforms and oranges that are specific to level 2. Ignore for now these lines, the controller dot something and the view dot something. Finally, we start simulation in this new level 2 world. If we continue the simulation by pressing this button here, we see that indeed we've jumped to level 2. Okay, let's return to these lines. What happens if we comment them out? I rerun the game, collect the oranges and go to the portal, but nothing happens. Moreover, I can no longer control the bird. Have I not transitioned to level 2? Well, let's debug. I will add a breakpoint here in goNextLevel. I restart in debug mode, collect the oranges, go to the door, and indeed this code gets triggered. Moreover, I can step through all of it, so I do transition. Why can't I see it? Well, because the view, this window into the game world, was attached to level 1. So even though you have a level 2 running just fine on your computer with physics and all, your view is stuck looking at the now stopped level 1. That's also why you can't control the bird anymore, because you've stopped level 1, so physics doesn't work there anymore. This is what this line does. It sets your view to track level 2 now, the new world, instead of level 1. So we want to enable it and then run the game again. I collect oranges, go to the door. Yes, I transition successfully now. Notice that physics works in level 2 because all these oranges fall to the ground. But wait, there's still one problem. I cannot move the bird. Why? Here's why. When you first created a controller that moves the bird, that allows you to move the bird, you've linked it to world get player. That is, you wanted to control world get player, the bird. But that's the bird that exists in level 1. And that's not this bird. This bird exists in level 2, and it's a new one. So we need to transfer the control from level 1 bird to level 2 bird. And this is what this line does. So that's it. If you run it now, you'll see that you've got working game levels. But before I finish, I want to look quickly into some extra features. These would come in handy for Milestone 2. For example, suppose we wanted each level to have a different background color. How might we do that? We'll use the same pattern. I create an abstract getBackgroundColor method in the base game level class, and I'll provide different implementations for it in each level class. So level 1 will return, say, yellow, level 2 will return blue, and so on. Then I'll use that method to get the right color for the level and apply it to my view. I could do it in game level populate, but the problem is that in game level I don't have access to the view object. So I'll do it where I do have access to the view, directly in game Java. So initially I call view set background color to world get background color here, thus setting the initial view background to the background of level 1. Then every time I create a new level, I reset the background of the view to the new level's color. What instead of color, you want a different background image for each level? Well, not much different. I'll let you figure it out. What if you want your orange values to be different for each level? So in level 1 you get 1 point for each orange, in level 2 you get perhaps 2 points. Or you want to have a different boss in each level. The idea is the same. You create an abstract method returning a value in game level with implementations that return different actual values for each level. And then you use those values to apply them to whatever game objects you want different. One more idea. The bird in level 1 is different than the bird in level 2. They are two different objects. That means that if I collected a bunch of oranges and I store them in my level 1 bird, those oranges don't get carried over in level 2 because you're creating a new bird from scratch in level 2. The solution? You need to manually carry over the oranges. So here's what I do. I'll add in the bird class a setOrangeCount method to set the number of oranges to a particular value, and a getOrangeCount to retrieve it. Then, when I switch levels, I keep a reference to the old bird and use it to transfer the number of oranges to the new bird. This will work. I will not demo it, but you can give it a try. So, levels are different worlds. Anything you want transferred between levels, you need to do so manually using this pattern that I've just shown here. Alright, good luck using levels in your Milestone 2.